Hello everyone. This is the topic Semantics of Call and Return Implementing Simple Subprograms from the third unit of Principles of Programming Languages. The subprogram call and return operations of a language are together called its subprogram linkage. General semantics of calls to a subprogram are parameter passing methods, stack dynamic allocation of local variables, and save the execution status of calling program, transfer of control and arrange for the return. If subprogram nesting is supported, access to non-local variables must be arranged. General semantics of subprogram returns. In-mode and in-out mode parameters must have their values returned. Deallocation of stack dynamic locals, restore the execution status, return control to the caller. Call semantics. Save the execution status of the caller, pass the parameters, pass the return address to the called function, transfer control to the called function. Return semantics. If pass by value result or out mode parameters are used, move the current values of those parameters to the corresponding actual parameters. If it is a function, move the functional value to the place the caller can get it. Restore the execution status of the caller, transfer control block to the caller. Implementing simple subprograms. Two separate parts are there, the actual code and the non-code part. Non-code part means having the local variables and data that can be changed. The format or layout of the non-code part of an executing subprogram is called as activation record. An activation record instance is a concrete example of an activation record. It consists of the collection of data for a particular subprogram activation. For example, here there are the subprograms A, B, C, and each subprogram there is an individual space for storing the local variables, parameters, and return address. And the entire space will be divided into data and code block. So this is called as activation record. The compiler must generate code to cause implicit allocation and deallocation of local variables. Recursion must be supported. The activation record format is static, but its size may be dynamic. The dynamic link points to the top of an instance of the activation record of the caller. An activation record instance is dynamically created when a subprogram is called. For example, in C function, a sub having two parameters and having some statements, and the list inside the function, there is a list have been declared with a size 5. So in the activation record there are 5 sequential spaces will be allocated to store the list of elements with the index 0, 1, 2, 3, 4, since the size of the list is 5. Caller actions. Caller will do the following actions. Create an activation record instance, save the execution status of the current program unit, compute and pass the parameters, pass the return address to the called function, and transfer the control to the called function. Prologue actions of the called function. The called function will save the old EP in the stack as the dynamic link and create the new value, and it will allocate the local variables. For example, a function without recursion. So in this example, we can see there are two functions, fun1 and fun2. Main function calls the fun1, fun1 calls fun2, fun2 calls fun3. An example without recursion. So here there are the functions fun1, main function calling fun1, fun1 is calling fun2, fun2 is calling fun3. So each function is having the activation record with the spaces for the local variables, parameters, and the dynamic link. The collection of dynamic links in the stack at a given time is called a dynamic chain or call chain. Local variables can be accessed by their offset from the beginning of the activation record. The local offset of a local variable can be determined by the compiler at the compilation time. So this is a activation record example for the factorial. So the factorial will have the functional value parameter, dynamic link and return address. The parameter is only one parameter, that is n. So that's all about the topic. Thank you.